In practice, you almost never use the definition of the derivative with limits. Instead, when you're trying to find a derivative, you use the basic differentiation rules. The first one we'll learn is the constant rule. And all of these rules I'll explain geometrically and analytically. So the constant rule says if you take the derivative with respect to x of c, where c is some constant, it gives you 0. The geometric interpretation is that the derivative gives you slope, and if the function whose slope you're trying to find, whose derivative you're trying to find, is a constant function, y equals c, the slope of every tangent line is the same, it's 0. It doesn't matter which point you're taking the tangent line to, the slopes are always going straight horizontal, the slope is 0. The more analytic approach to proving that is that we know from the definition of the derivative that f prime of x is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And since our function f is constant, it doesn't matter what the input is, it only gives you one output. Right? It's a constant function because the output's constant. No matter what you put in, you get c for your output. And so we subtract, giving us 0 over delta x. And if we try to plug in 0 at this step, it would give us 0 over 0, which is indeterminate. But instead, we simplify the expression in the limit to give you 0. Because since delta x is approaching 0, this delta x is not yet 0. And 0 divided by not 0 gives you 0. And the limit of 0 is 0.